Good day, everyone. Today we are going to talk about the video surveillance. There are 4 contents about this topic. The first one is the elements and means about security. And the second part is basic knowledge of security. And the third part is about the basic knowledge, including parameters, function, and AI function about IP camera. And the fourth part is about the parameters function about the NVR. Now let's begin with the first part, the security elements and means. So what is the security? The meaning is about the feeling safe and being free from worry, which means we can protect somebody or something from thieves, attacked, war, and etc. So basically, the security is just like the fence between our home and a stranger. Security consists of 3 elements. The first is detection, which means to predict risk through the detection, thus playing the role of event warning. Security consists of 3 elements. The first is detection, which means to predict risks through detection, thus playing the role of event warning. The second is delay. We hope to prolong the occurrence of events as much as possible. And the third is response. That is to take certain means to prevent the event from happening. There are 3 basic means of security: human, objects, and technology. Human refers to monitoring and management through security personnel, and objects refer to using some simple items to protect us, such as safes, security doors, etc. And the third is technology, which refers to the realization of security through the certain technology. Each method has its corresponding advantage. For example, the advantage of human is that the reaction speed is very fast. The advantage of the objects is that it can prolong the duration of the event. And the technology can play a very good role in preventing the occurrence of the event. Now let's move to the second part, the basic knowledge of security. So the first, we are going to know the development of the security camera. Since the 1970s, the analog camera was born, and is supporting the technologies including the matrix, VCR, and the other accessorial equipment. By the 1990s, we had DVRs that were able to convert analog to digital signals, which means that cameras has the network medium. By now, we have used the IP camera and NVR, officially saying goodbye to the analog cameras. This is the technology diagram of the monitoring system. which is divided into the three parts. The first one is video capture and encoding compression. The second part is the video storage and video distribution. And the third part is system management, user application, decoding display. For the surveillance industry, video surveillance is only the part of it. We also need other functions to support. In the first video capture, we also can use the PIR sensor, temperature sensor as the detection part. And in the second part, in addition to video storage, including NVR, cloud, and the transmission equipment should be included, such as switch. And the third part also needs to include the control unit, except the CMS, decoder, and LCD display. We also need the central control system to monitor and management. For the home users, you can refer to this simple topology. After the video is captured by the IP camera, if we want to watch the video or manage the devices, we can obtain the video data through the EZVIZ app or EZVIZ Studio, while the router is the camera and the client's data transfer medium between. So let's introduce the pictures and the video, which is image and video. Then first, let's take a look at this small video. From this video, we can see the difference between the pictures and video. So the image we can call the frame, which is static image. In the video, it's called a frame, like the one page. So the video is composed time continuous image. And for the frame, we can use the frame rate as unit of the frame. And the frame rate is frame per second, FPS, like the frequency of the page turning. The higher the frame rate is, the more fluent the video will be, the more the bit string will be. Next, we introduce some concepts of bit string. From the light entering our camera to the time when the rear camera converts the picture information into data and transmits it on the network. It can output 2 or even 3 kinds of bit string. The most common is the main string, which is primary string, which often contains the relevant large amount of image information, and is generally suitable for local storage, such as NVR and SD card. The second one is the substring, which has less picture information than the main string. It's generally used for the image transmission over low bandwidth network, which can reduce bandwidth. And the bit rate is the data bits transmitted unit time, kbps or mbps. And there are also 2 types of bit rate. the variable bitrate, and constant bitrate. The variable bitrate can adjust the appropriate transmission amount according to the network bandwidth, while the constant bitrate will not adjust the transmission amount adaptively. So, the video will be freeze if there is not enough bandwidth. Then let's talk about the pixel and the resolution. The pixel is that every image is composed of a lot of tiny color dots. For each color dot, we call this a pixel. Just like this heart, the red heart, the square will be the pixel of this whole image. And the amount of the all pixels, which is the resolution. And about the PPI refers to the number of pixels in unit length, which is pixel per inch. Then the relationship between them is the resolution equals inch times PPI. At the same resolution, if we reduce the size of the image, its pixel per unit area will increase, which will be more clearly reflected on the image. Conversely, if we increase the size of the image, the unit area pixel will decrease, and the image will become blurred. According to the resolution, we define a pixel larger than 1 megapixel as HD, and a pixel larger than the 2 megapixel as Full HD. There is a close resolution between frame rate, resolution, and bitstream. As can be seen from this figure, the three of them are proportional to each other. As frame rate and resolution increase, the bitstream will decrease as well. If the picture is uncompressed, how much video capacity will be generated? For example, the 4C. A frame in the 4C resolution picture is about 152,000 bytes, and in 1 second, it will be the 3.63 megabytes per second, and for an hour, it will become the 12.75 gigabytes per hour, and in a day, there will be the 0.299 terabytes per day. This will occupy a very large storage capacity, and the bandwidth cost will also be greatly increased. At this time, we will introduce the concept of compression. In fact, a lot of data in the video content is repeated, so we can consider reducing the capacity through compression. There are two types of compression techniques: spatial redundancy and time redundancy. The spatial redundancy means that only the data of this frame is considered for compression. And the time redundancy refers to the redundant information between the adjacent frames in the compressed continuous video, which is suitable for the case where the frame change is small. The main difference between these two techniques is that spatial redundancy only refers to the data of this frame, and the compression rate is small, while time redundancy refers to other frame data, and the compression rate is large. This is the development of the compression standard. Earlier in video surveillance, MJPEG, MPEG 102, MPEG4, and H.264 ABC are the main coding standard. Nowadays, we're using the H.264 and H.265 are the most widely used standards. For the EZVIZ products, we have used the H.265 encoding technology from the 2020. In general, cameras that support H.265 will also support H.264. This is the main difference between the H.264 and H.265 technology. Under the same picture, the required bandwidth and storage capacity are halved from H.265 compared with H.264. Under the same bandwidth with complicated image, the picture is clear for H.265 compared with H.264. This is the basic formula for calculating the file size as follows. The file size, gigabytes, is equal to the bit rate divided by the 8, which is the unit convert, and divided to 1024, which is the convert unit as well, and divided to the 1024, it's a megabyte convert to gigabyte, and then times the 3600 per second, which is hourly. Then let's move to the third part, which is IP camera's parameters and the main function. The first question is, what is the IP camera? The IP camera is kind of the camera that supports the network protocol, so which we can call it as Internet Protocol camera. The IP camera works as the follows. Light enters the sensor. The sensor converts the light signal into an electronic signal, which is analog signal. The analog signal is converted into the digital signal by the ISP module. And then the raw data is compressed and transmitted by the DSP module. And about the NET, which will help the data encapsulation to the specific destination, such as MBR or the other client. This is the main difference and compared between the CMOS sensors and the CCD sensor. The CMOS sensor will be output the digital signal, while the CCD will output the analog signal. So it will need to work with AD converter. And about the sensitivity, the CCD sensor will be higher than the CMOS. And the cost, the CMOS is lower than CCD. And the power consumption, the CMOS is lower than the CCD. And about the image quality, we recommend the CCD because it's higher than the CMOS. And about the signal noise ratio, the CMOS is lower than the CCD. As the development of CCD and CMOS, the gap between them is narrowing. The new generation of CCD is improving in power consumption, and CMOS is improving in the signal noise ratio and sensitivity. For the EZVIZ product, we use the CMOS sensor. There are two ways to scan pictures in IP camera. Interlacing scanning. The first is interlacing scanning, in which the pictures are scanned twice according to the odd and even fields. And the second one is progressive scanning, which scans the pictures in sequence at one time. Then we can see the difference between the interlacing scanning and progressive scanning. The progressive scanning can prevent the problem of shadow phenomenon caused by the fast-moving objects and make the image smoother. And the next parameter is lowest illumination. Camera can output image normally under the lowest illumination environment. It can also be called sensitivity. The unit should be lux. So for the camera, if it's 1 to 3 lux, then we can call this normal camera. And for the 0.1 lux, it can be called moonlight camera. And if the lowest illumination is lower than 0.01 lux, it should be the starlight camera. And for the IR light camera, the lowest illumination should be 0 lux. Light complementary by IR light. And the camera's lowest illumination parameters is shown below. The color or the black-white and the lowest illumination and the apertures in the at the end. The next parameters is IR cut. In the daytime, when the light is sufficient, the filter will switch to IR cut mode, under which only visible light is allowed to enter the camera. We can enjoy the original color of scene. And in the night, when the light is insufficient, the IR cut filter is removed and switched to full permeability spectral mode, under which all the light can be used for night vision, even in a low illumination environment, such as this picture. And there are two types of IR technology. The first one is active IR, which is depending on the support of external light source, making use of image sensors' ability to sense IR light and visible light, fulfilling the function of night vision. And the second one is passive IR, is infrared thermal image technology. The next parameter is smart IR. Intelligent image processing technology is used to automatically adjust the brightness curve by detecting the multi-block brightness of the image. This will help to solve the problem of IR overexposure near the camera. So we can see the pictures that difference between the smart IR on and off. The smart PQ, which is based on the intelligent sensing of the actual environment, the intelligent PQ technology is used to adjust the screen brightness to improve the picture quality of the humanoid area and keep the humanoid area clearly visible. About the AGC, automatic gain control. This will help automatically increase the sensitivity of the camera under dark environment for a clear picture. However, it will enlarge image noise at the same time. The other parameters is 3D DNR, the 3D digital noise reduction. Normally, the surveillance camera compares and filters the images of the two frames before and after, so as to find out the noise, position, and gain control. The 3D DNR function can reduce the noise interference of the weak signal image. And about the white balance. The white balance can guarantee the right color displays in different color temperature environment. There are two types of the white balance. The automatic white balance, which is default settings, and you can also use the manual white balance to adjust the color about the display. In the backlight scenes, these two functions can make the particularly bright and dark parts scenes at the same time, which are the BLC background light compensation and WDR wide dynamic range. Generally, the WDR works better than the BLC. You can refer to the pictures below. And for the WDR technology, there are two types in this technology. The wide dynamic range based on the digital algorithm, and the other one is the true wide dynamic range, which is based on the hardware. So the DWDR is realized by the algorithm. The TWDR takes two images with long exposures and short exposure, then compare them to create a final image with better light balance. Therefore, we can refer to the picture below and shows that TWDR works better than the DWDR. And the next parameter is lens focal length. The lens focal length is the distance from the optical center of the lens to the focus of the light when the parallel light is entering. The lens focal length determines the size of the image taken, the field of view, and the depth of the field. From the camera lens, there are two fields of view. The first one is diagonal view angle, and the second one is horizontal view angle. And there's a relationship between the focus length, distance, and FOV, field of view. You can refer to the film here. The larger the focal length, the further camera can capture, the smaller the field of view will be. And for the other situation, the smaller the focal length, the nearer cameras can capture, and the length of and the larger for the FOV will be. And how to choose the lens? So for the recommended surveillance distance, it means that the best distance for seeing human shape. For example, if you want the 0 to 3 meters that can capture the human shape, you can choose the 2.8 millimeters. And if you want to capture the human shape between the 3 to 5 meters, you can choose 4 millimeters lens, and etc. And about the shutter speed. The lower the shutter speed, the longer the exposure time, the lighter the image will be. And the higher the shutter speed, the shorter the exposure time, and the darker the image will be. One thing to note is that there might have a shadow phenomenon for the fast-moving objects. And this is the film to introduce the IP dust and the waterproof. So you can refer to the IP grid to see the function about the dust proof and waterproof, the level. And about the detection, the main function of the EZVIZ camera is motion detection. The captured image is calculated and compared by the camera according to the certain algorithm. Then the camera does some response according to the results. For example, when someone passed by, the user will get the alarm notification from the EZVIZ app. It should be noted that motion detection captures motion information based on the screen change, the image change. So weather change, such as rainy day or the snowing day, will also trigger the detection, which is the major drawback of the function. For the PIR detection, the detector itself does not emit any energy and other passively receives and detects infrared radiation from the environment. Only warm animals can release the infrared signal. So this function can prevent the curtain movement, insect movement, and the lighting movement. However, if the weather is weather degree is very hot and the degree is higher, and if the car passed by in front of the sensor, the PIR sensor also can be triggered. This is the disadvantage of this function. Then let's can compare the motion detection and the PIR detection function. The similarity between these two functions for the IPC, the work process of these two detections is similar. So first, the movement can be triggered, and the camera capture the changes between the different image. And then the IPC, IP camera does calculations and comparison according to the certain algorithm. And the fourth step, the results indicate the system doing some responding. And about the difference, the triggered signal is different. The motion detection is triggered by the movement objects, and the PIR detection is triggered by the infrared radiation. So the PIR sensors can prevent the light change, flying insects, and the curtain flutter. And also it can prevent the raining day or the snowing day, that's specific weather. For the PoE connection, the power over Ethernet technology, without any change to existing Ethernet cabling infrastructure, it can supply DC power and transmit the data at the same time, which is very convenient for the end user. And there are two types of the PoE technology. The PSE, which is the power sourcing equipment, such as PoE switch, PoE MBR, etc. And the other one is PD, the power device. Which should be the PoE IP camera and PoE AP, etc. And the other AI function is face recognition. The face recognition is the technology that automatically performs identification based on the person's facial features. It used multiple technologies such as digital image, video processing, and pattern recognition. So the workflow is shown below. So first, the face will be detected, and the face tracking, and it will capture the face and compares with the result and output the result. The front-end camera function. The whole process of face capture face comparison, output result, such as alarm and push. This function has the advantages and disadvantage. The advantage is the bandwidth requirement is small. The second one is after the network is disconnected, once the network is restored, and the alarm push can still be uploaded to the platform. And it costs a lower deployment. The disadvantage is the face library is small, which is suitable for the small scenes. And about the other face recognition is back-end face recognition. The face capture face pictures are transmitted to backend device through the network. After the backend server finishes the picture comparison, it will output the result. such as alarm and push notification. The advantage of this backend face recognition, the face database is huge, which can be connected with the public security face database of the entire city, and applicable to comprehensive scenarios. Multiple scenarios can be used together. And the human shape detection is a data module established by the combining body shape and motion range. Currently, our EZVIZ product in the IP cameras that support this human shape function are the C3N, C3W Pro Color Night Vision, C6C and H.265, CAC, and C3X. And for the vehicle shape detection, it's a data module established by the vehicle body shape. And this function is only available in the C3X module. Now let's move to the last part, the MVR, parameters and function. The mainly function of the MVR is centralizing the storage and the retrieval audio and video data from the Internet. When the IP camera captures and coding the video stream will transmit to the Internet. And through the Internet, the video stream will finally stored in the MVR. There are many parameters to measure the performance of MVR. The first one is IP camera accessibility, which including the maximum resolution and channels. The maximum IP camera resolution that MVR supports to access. This is the maximum resolution ability. And the other ability is about the connection channel, the maximum IPC number that MVR can access at the same time. The common MVR channels are 4 channels, 8 channels, 16 channels, 24 channels, 32 channels, and 128 channels as well. And the other parameters to measure the MVR performance is video output. MVRs generally contain 2 video output interfaces, VGA and HDMI. Compared with the HDMI, the VGA outputs the lower quality image and transmits the analog signals. And the biggest disadvantage is that VGA does not support the audio signal transmission, while HDMI supports audio and video signal transmission at the same time. And it supports higher resolution than the VGA interface. And the other parameter is open protocol. The common open protocol is EZVIZ. It's a kind of global open interface standard to ensure that intercommunity of network video products from different manufacturers. And about the HDD, hard disk drive. Normal HDD used in the normal PC, the personal computer, and it costs a lower price, and it performs the general features, and it works 5 times 8 hours. However, the video surveillance HDD normally is used in the video surveillance. It supports higher reliability and good vibration resistance, and it can work the whole day in the week. The common video surveillance HDD storage capability are 1 tera, 2 tera, 4 tera, 6 tera, and 8 terabytes. It is very important to choose the video surveillance HDD for the NVR. An NVR can output the video or audio signal via VGA and HDMI interface for live view and playback. This is a mainly function about the NVR. And it supports dual bitstream, the mainstream and substream as well. And the other function about the NVR is shown at this picture. It supports the live view, playback, export the video, storage, and the manual, and the HDD, and manage record video settings, and connect the camera, configure the camera, and maintenance the main features about the NVR, and it can also be shut down. And thank you for listening to this topic.